We've got one more day of chain rule stuff, and this is really not anything new, but we're going to do problems where we have a chain rule inside of a chain rule. And so you have all the techniques you need to be able to do these problems right now, but I'm going to do a few of them with you because sometimes they can get kind of a little complicated, especially keeping track of what's going on. So if I look at this first one, this looks like a chain rule. I have a function sine of x inside of e to the x. So my outside function is going to be e to the x, and my inside function will be sine of 4x. The derivative of e to the x is e to the x. And then this is where things get a little bit more interesting. When I try to take the derivative of sine of 4x, I have a function inside of a function because 4x is itself a function. So I'm going to need to do the chain rule again. So let me kind of highlight this. We'll do this in a different color. So I'm going to do the chain rule just on the sine of 4x piece. So in this case, my outside function is sine of x. My inside function is 4x. Thankfully, both of those pieces are nice. So the derivative of sine is cosine. The derivative of 4x is 4. So when we put these together to get the derivative of sine of 4x, we're going to plug the 4x inside of the cosine. So we're going to get cosine of 4x. And we'll multiply that all by 4. So I'm just going to put the 4 on this side. Okay, so we're not done yet. That was just the chain rule for the inside function. So now we have to put all this back together. So my original outside derivative, I'm going to plug the sine of 4x into that. So I'm going to get e to the sine of 4x, and then I'm going to multiply by the derivative of my inside function. So multiply that by 4 cosine of 4x. And that's my final answer. So we have two chain rules in this problem. And we're probably going to have something similar in these other problems. There's no reason to stop with two chain rules. You could do a chain rule inside a chain rule inside a chain rule. Usually I'm not going to be that cruel though. Okay, so let's look at this one. So again, this looks like a chain rule. My outside function, or usually easier to find the inside function. The inside function here looks to be the 10x minus 4e to the negative x. The outside function, that is x to the 6th. The derivative of the outside function, 6x to the 5th. The derivative of the inside function, I get 10. Okay, so now this is where I have to be careful. This piece is not just an e to the x, it's e to the negative x. Again, it's tempting to say that the derivative of e to the negative x is e to the negative x, but it's not. So we need a chain rule again on this because we have a function. We have something besides just an x and the exponent. So let's look at that. So it looks like my outside function will be the negative 4e to the x. The negative 4 is just a constant, so you could forget about it if you wanted. You could just like rewrite the negative 4 up here and then find the derivative of e to the negative x, kind of however you prefer. So the derivative of this guy is negative 4e to the x. My inside function is just the negative x coming from that exponent. Its derivative is negative 1. So when we put this all back together, I'm going to plug the negative x into the derivative of the outside. So I have negative 4e to the negative x. And I'm going to multiply everything by negative 1. So when I simplify that, I get 4e to the negative x. Okay. And so then that was the derivative of this piece. So I have to add that to the 10 plus 4e to the negative x. Okay, again, I'm not actually done yet. That was just the derivative of my inside function. So now I'm going to put all of this back together. I'm going to plug my inside function into the derivative of my outside function. So I get 6 times 10x minus 4e to the negative x, all to the 5th power. And then I'm going to multiply that by the derivative of the inside function. Okay. And really, the best way to think about these is when you look at them, they might be overwhelming and you can tell that you might need a chain rule inside of a chain rule, but just start working through them systematically. Start with what's the outside most function, what's my inside function, and then just kind of work from there. If you try and like bite off more than you can chew in these problems, it gets overwhelming. So you just want to take it in small pieces. Okay, so let's do this one here. So the outside most function is sine of x in this case. So we're going to pick that to be our outside function. We kind of want the most simple thing out there. Its derivative is cosine. The thing inside of my sine is a little more complicated. That's cosine tangent. And notice that this is cosine of tangent, not cosine times tangent. If it were cosine times tangent, it would be written cosine x tangent x. But instead, this is cosine with tangent plugged in. So this is going to be a chain rule because we have a function inside of a function. So, okay, so we're going to practice this. And hopefully you guys are trying this on your own before you watch me do it. Here, the outside function is cosine, and the inside function is tangent. Derivative of cosine is negative sine. Derivative of tangent is secant squared. When we put these back together, I'm going to plug tangent into here. So I get negative sine of tangent and then multiplied by secant squared x. Okay, and so that was the derivative of my inside function. Okay, and now again, not done. We're going to put this all back together. I'm going to plug my inside function into the derivative of my outside function. So I get cosine of tangent of x multiplied by all of this. Make sure you've got parentheses there because of that negative, or you could move the negative out in front of everything. So we have sine of tangent times secant squared. Okay. So we're going to get more practice with these in class. Again, just do them systematically and don't try not to get overwhelmed by them.